All right, here's a good question. The question, I think, asks for what is the amplitude? What is the phase shift? And it could also ask for the period. And maybe might as well throw in vertical translation. That's all of them, right? So, in other transformations we've done in the past, we've just said this letter's A, this letter's B, this letter's C, and one out back here would be D. And then we've said A and D affect Y values, B and C affect X values. And that's true for sine functions as well. But with sine functions, there's some different concepts. Because a sine function is a periodic function, we can talk about different things with it. And so let me just deal with A and D first, and then I'll talk about that. So A is the vertical stretch thing, and so it's going to vertically stretch the graph by a factor of 2. And if you're looking for your amplitude, the amplitude, regardless of whether that 2 is a positive 2 or a negative 2, it is positive, but either way, the amplitude is 2. Okay, so the amplitude is whatever A is equal to. And I guess I would say it's the absolute value of A. So I wouldn't ever say the amplitude is negative 2. The amplitude's 2. Okay, and then vertical translation, I'll do that one next. Vertical translation, does the graph go up or down? That's the D value. And in this case, D, there's no D, so we would say it'd be 0. So it's not moving up or down. Okay, now let's look at B and C. So the value of B in trigonometric functions or sine or cos functions, the value of B helps you determine what the period of the graph is. And the period means how long does it take the graph to start over again. So this graph could keep going on forever. Like this way, it's periodic. But period is how long does it take from the start of a shape until it finishes and starts that again. So this distance here is period. And you always get the period. You can't just look at the number there. The period is always 2 pi divided by whatever B is. So in this case, it's 2 pi divided by 1/3. And so that's 2 pi divided by 1/3, or 2 pi, pi, times 3/1. Right, dividing fractions, invert and multiply. So 2 pi times 3 would be 6 pi. Okay, so the period of the graph would be 6 pi. In other words, if a normal graph looked like this red one, that usually is 2 pi. So this graph would take a lot longer to do one period. Because that's your period. The next one is your phase shift. So phase shift is moving the graph left or to the right. And usually we've just said, hey, it's whatever C is. And you can say that if there's no B value, but if there's a B value, it complicates that. So what I do is for phase shift, the formula is always whatever C is divided by B. So if there's no B value, then it's just whatever C is. But if there's a B value, then you've got to divide them. So C in this case is pi/3, okay, divided by B is 1/3. So when I invert and multiply, so pi/3 divided by 1/3. So let's invert and multiply. So the 3's will cancel out. So here the phase shift is pi. But remember, with phase shift, you always have to say what direction it's going. And again, because of that sign there, and it's always opposite to what you think, this would be, the graph would shift to the right by pi units. Okay, now let's just sort of confirm that with some decimals, just to see if we're right. Okay, graphing calculator. Okay, so let's just first graph y equals sine, where's sine? Sine of x. There's the normal graph. Let me make that a little bit bigger. Beautiful. Now let's put a 2 in there and see what happens. Y equals 2 function sine x. Okay, so notice that all that happens with that graph, it crosses the x-axis at the exact same spot, but all that happened with the graph is it's now going, the amplitude's 2. It's going higher and lower. Okay, now if I put a 1/3 in right there, 1 divided 3, notice that the graph now is taking a lot longer to complete one revolution or one period. Okay, and that's what we sort of thought. Okay, good. And then let's put this number in here, minus pi, where's my pi? Oh, there's pi, divide 3. There. Okay, now that's given me some trouble because I'm trying to put 3 transformations all into one. But let's take a look. Basically, I said up here, the graph moved pi units to the right. So here is where the normal graph starts, and here's where my graph started. It got pushed over to the right. So if I take a look at what number that is, it'd be 1, 2, this would be 3 and a little bit, right? And if you look at how far we moved over, it was pi, and pi is 3 and a little bit. Okay, hopefully that helps you figure out the phase shift, the period, and the amplitude of a graph.